So today we're going to be talking about the Maillard reaction and various different examples of it.
The Maillard reaction occurs during cooking and is responsible for non-enzymatic browning of food when cooking. It actually consists of a number of reactions and can occur at room temperature. One example of the Maillard reaction is coffee. Coffee starts out as a green bean that comes from a flower. When you roast the green bean, they turn a darkish brown color, which is the coffee we are used to and we drink. The darker the bean, the stronger the coffee will be, and the more bitter it will be. Also, the beans tend to get bigger the longer you roast them. Lighter coffee tends to only have one crack during the roasting process, but much darker coffee can have up to two cracks and more during the roasting process.
Have you ever wondered what causes the golden brown color of all baked goods? It's because of the Maillard reaction. The Maillard reaction, also known as browning or caramelization, occurs when proteins undergo a chemical reaction with reducing sugars upon applied heat. More specifically, proteins, peptides, and the free amino groups of amino acids react with free reducing sugars to produce desirable flavors, aroma, and crust coloring in many baked goods. These baked goods include bread, rolls, crackers, cakes, biscuits, and any other baked item possible of producing a crust. Lactose, fructose, and glucose are the most common reducing sugars found in breads. The reducing sugars and amino acids react together in three distinct stages to complete the Maillard reaction. The initial stage is undetectably colorless on crust and enables the sugars as well as the amino acids to condensate. Moving into the intermediate stage, which ranges from colorless to light yellow crust, the sugars dehydrate and become fragments. At the meantime, the amino acids begin to degrade as well. The final stage is where the most color is produced and exhibited as a golden brown on the crust of the baked item. Once each stage has passed, the Maillard reaction is complete with many aromatic and flavor compounds being produced. These create high-quality baked goods and exhibit positive final product attributes such as crust color, crumb grain, volume, and mouthfeel. This is the full process of bread to baked bread.
Most of meat's flavors develop when it's cooked. The Maillard reaction occurs when the denatured proteins of the surface of the meat recombine with the sugars present. The combination creates the meaty flavor and changes the color. For this reason, it is also called the browning reaction. The Maillard reaction occurs most readily at around 300 Fahrenheit to 500 Fahrenheit. When meat is cooked, the outside reaches a higher temperature than the inside, triggering the Maillard reaction and creating the strongest flavors on the surface. The Maillard reaction is the principle behind the browning of meat when a sear has a prelude to braising it. This process creates a thick, dark brown crust on the surface of the meat that enhances its appearance and flavor, and can only be created by high temperature, dry heat cooking technique. Note that one of the prerequisites for obtaining a dark brown crust on your meat is ensuring that it's dry before you put it in the pan. If it is too wet, the moisture will cook off, forming steam, which interferes with the browning process and tends to produce a gray interior rather than brown. Also, make sure that you get your pan very hot before adding the meat. A cast iron skillet is excellent for browning meat because it gets very hot and maintains that temperature very well. So next time, be brave as you sear the steak and get that brown because brown is flavor.
Um, Bacon's actually another one of those things that has a large appeal, which is due to the Maillard reaction as well. And that's because when you heat bacon, what you're essentially doing is you're creating a chemical reaction between an amino acid and reducing sugar. And it's the acid and the sugar that actually react with each other, and that's where you get all the smells and the flavours. And I think even the most committed vegetarian can't deny that bacon does smell actually pretty decent.
Another example of the Maillard reaction is the chemistry of beer. We have thousands and thousands of molecules that make up what we know as beer. The variety of brown colors, flavor, and aroma is obtained through the Maillard reaction. This non-enzymatic browning is very common and mostly occurs with high temperatures. This occurs through a combination of amino acids, particularly alpha and beta acids, while reducing sugars. Alpha acids are found in the hops using for browning. They degrade to form iso-alpha acids, which contribute to bitterness. Beta acids also originate from hops and add bitterness during the fermentation of the beer as they are slowly oxidized. These amino acids are going to be used for nutrition for yeast during a fermentation process. This is when you will notice the browning, flavors, and aromas. The sugar is reduced from carbohydrates, specifically amylose. Amylose is broken down into maltose and glucose. This reduction of sugars aid in reducing other components.